Hello, today we are going to talk about exponential functions, how to create them, and also how to graph them. First, we're going to look at the first equation we have. We have y equals a times b to the x power. That is the equation that you use when you have a growth factor. And if you look, when you're doing it, the a is always your initial value. That's your initial value or your starting point. And then your b is your growth factor. And that is usually a growth factor when they say when it's double, triple, half, or different words like that, where they're telling you exactly what's happening each and every time. So anytime that you're given one of those, you have to use that particular formula, y equals a times b to the x power. Now, if you're given a percentage or a rate of growth or a rate of decay of something growing or declining, you have to use the growth rate formula, where you have y equals a times the sum of 1 plus or minus whatever your rate is, raised to the x power. The biggest thing to know in that one is that the rate is usually a percentage, and it's very important that you convert that percentage either to a decimal, or when you're plugging it into your calculator, make sure you hit the percent button and it'll automatically convert it for you. The other thing is, when you're to graph these, probably the easiest way is to know what they're supposed to look like. That's why we have the examples written here. You have an exponential growth that is going to look like that. It's going to always look like it's going up. It's going to look like it levels off at the bottom every time. And then the exponential decay is going to start up high and it's going to go down rapidly, and then again levels off. We will go into more detail about exponential functions later, but these are the basic things we want to know about the graphing we want to do right now.